Hey you guys! So what we're going to do first is we're going to learn how to do some moles to moles conversions. But before we can do that, you have to have a balanced chemical equation. That's very, very important. So that's the very first thing you should do before you can do any type of conversions at all. So you always have to have a balanced equation. So if you're ever given a question and it doesn't actually give you the equation, it gives you the word format, you need to figure out what your balanced equation is going to be before you can do anything else. Here, as you may notice on the board, I already have a fully balanced equation. So what we're working with is iron 3 oxide is going to react with carbon monoxide in order to produce iron and carbon dioxide. Now, what we use this balanced equation for is to figure out what our mole ratios are going to be. And where do you get those mole ratios from? Your coefficients. So let's do an example of a mole ratio. We're going to look at our coefficients. And remember, if you don't see a coefficient out in front of a compound, it's an understood 1. So that means I have 1 mole of iron 3 oxide for every 3 moles of carbon monoxide. Now all I did is I looked at my coefficients. I had an understood 1 coefficient for iron 3 oxide, and then I had a 3 coefficient for carbon monoxide. So I plugged that in as a ratio. You can even say 2 moles of iron for every 3 moles of carbon monoxide, or 3 moles of carbon dioxide for every 1 mole of iron 3 oxide. It's very versatile. What's really cool about these coefficients or these mole ratios is they act as a conversion factor. So when we plug it in to actually do some math, it's going to be perfect and it's going to make it super easy for us. So let's do some problems in order to help better explain what we're doing. So say for example, I gave you 5.0 moles of iron 3 oxide. Okay? I wanted to know how many moles of carbon dioxide were needed in order to react with this 5.0 moles of iron 3 oxide. Now, what's really important here, and this is what I like to do before I do anything, anytime I read a problem, I like to pull out that important information to help keep things a little bit more organized and on track for me. So my starting point was the 5.0 moles of iron 3 oxide. So I wrote that down here. And over here to the side, I wrote down what my destination is. What am I trying to solve for? And what I'm trying to solve for is moles of carbon monoxide. So again, this helps keep it a little bit more organized for me. And then if I ever have questions like, wait a minute, what am I trying to solve for? All I have to do is look over here. I'm like, oh, that's right, I'm trying to solve for this. Keeps it a lot more organized so you don't get swapped up in all of your numbers and your compounds. So all I have to do for here is just plug in my mole ratios. So I'm going to create the T-chart. You guys should already be familiarized with the T-chart. Now, when I look at this, I need to change from one compound to another compound. I need to go from iron 3 oxide to carbon monoxide. So I'm going to use my mole ratio. So I'm going to look up here. I see I have a 1 coefficient for iron 3 oxide, and I'm going to plug that down here in the bottom. So I have 1 mole of iron 3 oxide. And then up on top, what I'm going to do is I'm going to put my 3 moles of carbon monoxide up there. Now, why did I choose to put the 3 moles of carbon monoxide on top and the 1 mole of iron 3 oxide on bottom? It all has to do with what you need to cancel out. So if you look at this, you start out with iron 3 oxide, but you wanted to convert it to carbon monoxide. So I needed the iron 3 oxide on bottom, so these two will cancel each other out, leaving me with my destination of moles of carbon monoxide. That's very important that your final destination is going to end up on top. When I go through and I do this math, I'm going to end up getting 15 moles of carbon monoxide. Now remember, anytime you're doing any of this math, you have to use significant digits with your answer. Okay? So when you do that, you're going to look at your starting point. I had 5.0. I have 1, 2 significant digits. Now keep in mind, this 0 is significant for this number. The reason why is it comes after a non-zero and there's a decimal present. So I have 2 significant digits. I'm going to come over here to my answer and have 1, 2. We already have our answer in 2 significant digits. Fabulous. It means we don't actually have to do anything else to our answer. Let's try another problem. So what we're going to do is I'm going to put up a slide, and it's going to give you a practice problem to do. Once you read that practice problem, I would like for you to pause the video. When you pause the video, I want you to practice this on your own first. Once you have completed practicing it, push play again to restart the video, and then we're going to work it on the board. So this way you can kind of really just test yourself to see how you're understanding the material. So in the practice problem that you've been provided, you're going to see that you're trying to figure out how much carbon monoxide is needed in order to produce 6.78 moles of iron. So let's pull out that really important information in there. So my starting point is going to be the 6.78 moles of iron. And again, I have to figure out how many moles of carbon monoxide are needed. So my destination is going to be moles of carbon monoxide. Well, since I'm in moles, I can go from moles of iron to moles of carbon monoxide using my mole ratio. So I'm going to look for iron up in my balanced equation. I see I have a 2 coefficient out in front of it. So I want to put 2 moles of iron on bottom. Again, my outcome that I need needs to be in moles of carbon monoxide. So I look at my balanced equation. I see I have a 3 coefficient. So I'm going to put 3 moles of carbon monoxide up on top. My moles of irons will cancel each other out. And then all I have to do now is just do the math. When I do the math, I should actually get 10.17 moles of carbon monoxide. But am I done? Nope. Remember what I said, your answer needs to be in significant digits. So let's go back to our starting point. How many significant digits do we have? We have 1, 2, 3. 3 significant digits. So if we come down here to our answer, we have 1, 2, 3. I'm going to round that 1 based off the number behind it, which is a 7. So since it's a 7, that means I need to round it up. So that means I'm going to have 10.2 moles of carbon monoxide as my answer. Now this is something really important to know. So if you need to, put a big star beside it, whatever you need to do in order to make it stand out to you. When you're doing these conversions and you're going from one compound to another compound, it's very, very important to realize the only time you can do that is when you're actually in moles. So we're going to be going forward and learning some other conversions that are going to be dealing with grams. And you can't really go from grams to moles, grams of one compound to moles of another compound. You have to get it to moles first. So put a big star beside it. The only time you can convert from one compound to another compound is when you're in moles. Again, that would make a lot more sense once we actually get to those sections. Now from here, what I would like you to do before you move on to the next video is we're going to have some practice problems uploaded into Moodle for you. It's only going to be about 3 or 4 problems. So this is going to help test you to see how you're feeling about the material from this point. So from here, stop at this video, go to the practice problems, practice this out. Once you feel comfortable with it, you can move on to your next video. See you next time.